The maker movement is exploding these days. New technologies like 3D printing, cheap microcontroller and microprocessor boards, and easily available how-to information on the internet make it so that aspiring inventors can create amazingly techie things in the comfort of their own garages, basements, dining room tables, or, well, we don't want to know. Anyway, making anything cool with technology requires math. Behind every fancy robot, quadcopter, whizzo, gizmo is a differential equation or two slaving away to make everything possible. That not-so-secret weapon of people who do math is a program called MATLAB from the MathWorks. MATLAB makes even the most complex math easy, which gives you more time for software and soldering. But how do you get your math from the abstract software world into your actual plastic and computer chips and baling wire project? We could all use some help with that. Hi, I'm Amelia Dalton, host of Chalk Talk, and my guest today is Amnon Guy from the MathWorks, and we're going to talk about how you can use MATLAB and Simulink in your hardware projects. Turns out it's easy, fun, and completely affordable, even on your basement project budget. Before we get started, remember to click that link. There you can download a free tech packet that has all sorts of cool stuff all about how the MathWorks connects to hardware. Hi, Amnon. Thank you so much for joining me today.
Glad to be here, Amelia.
So, what the heck was the MathWorks doing at the Maker Faire in New York City?
MathWorks was showing how easy it is to connect MATLAB and Simulink to Arduino, Raspberry Pi, and Lego to do cool, fun projects.
All right, so how easy is it?
It is very easy. It is as easy as getting your MATLAB and Simulink and then downloading a hardware support package for one of the platforms we see here.
Excellent.
And you can use MATLAB to acquire data from your iPhone or Android phone or collect data from an analog discovery platform.
Cool.
If you actually don't want to just to collect data and you actually want to develop an algorithm and then implement it on the specific hardware, you can use Simulink, develop your algorithm, and then using automatic code generation, deploy this code onto your Arduino.
Very cool, okay.
Or Raspberry Pi, or Lego,
Uh-huh.
or any of the other low-cost boards that we support.
Fantastic.
And to make it even more easier, we created a Maker Zone site with project ideas and examples.
Very cool.
We call it the Maker Zone, and you can find it at makerzone.mathworks.com. And this is where the community of the makers can get started with examples of how to program Arduino, how to program a Raspberry Pi, but also pose questions and get direct answers from our community.
Super cool. All right. So what kind of projects are you seeing makers do?
Oh, we see a wide range of projects.
Okay.
We've got makers who just like playing with LEDs.
Of course.
And one of them actually developed the Arduino that senses love.
Oh, that's cute.
And every time there is a motion around the Arduino, the LEDs go in the shape of the heart, as we see here.
I like it.
And very aligned with the community practices, most of the files that the Maker community going to develop, they're going to put it up there in the MATLAB Central so everybody else can use them too.
Excellent.
These guys are all about sharing. It's awesome.
Nice.
There are also a category of folks who are fascinated with robotics.
I love robots myself.
If you go to the Element 14 site, I think you see dozens of robots based on Arduino and Raspberry Pi.
Mm-hmm.
Here's an example of a robot project using the Zumo robot.
Nice, okay.
And I think the algorithm here has to do with the line follower and of course the folks who got a little bit more advanced and added a controller, a PID controller.
Okay.
And the fun thing is that even if you are a maker who doesn't really know much about PID control, you can actually very visually understand what the PID control is about.
Sure, yeah.
And maybe later on understand what happens if you draw the P or the D or the I. And again, all the files are going to be available on MATLAB Central.
All right, so now back to the makers. So why makers, and what is the MathWorks doing to make MATLAB and Simulink accessible to the maker community?
Well, Amelia, because Kevin Morris says so.
Really? Okay.
But to be honest, there are some couple of other reasons why. And when you look at who the makers are, the way they talk about themselves, and the areas that they are interested in, They're interested in the same thing that we in the industry are interested in. They're interested in science, electronics, and robotics.
Mm-hmm.
It's true that some of them are engineers, but most of them are not engineers. So not being an engineer and trying to program a hardware, you're probably looking for easier tools to get up with your hardware project.
Right.
And MathWorks has the high-level environment that allows you to take advantage of thousands of pre-built blocks for control, for image processing, for vision, and so on and so forth, without needing to write any line of code.
Nice.
And most recently, in order to support the maker community, MathWorks announced the MATLAB Home.
Okay.
Guess what is it for?
Home?
That is for home. This is for the maker community to use MATLAB and Simulink at home. And MATLAB Home gives you the full capability of MATLAB for personal use.
Nice.
And we see folks using MATLAB and Simulink for personal projects, such as some of them doing stock market analysis.
Huh, okay.
Others are enhancing the digital photos. And of course, there are always those who are trying to show off their robotic skills and Arduino and Raspberry Pi capabilities.
All right, so I'm not quite completely buying that Kevin Morris reason, just so you know.
Well, I think you got me. It's not all about because of Kevin Morris. I think the key reason is because the maker community is the convergence of two markets that MathWorks has been serving for 30 years.
Mm-hmm.
It's the academia
Right.
and the commercial market.
That's interesting. So tell me more about how students and engineers are using MATLAB and Simulink with hardware.
Many, many years ago, when I did my engineering degree, we used MATLAB to do some FFTs, some plottings, and maybe learn about control theories.
Uh-huh.
If I'm not mistaken, I think we actually used the TI EVM 6713 floating point DSP
Okay.
to test some of our very simple audio algorithms. But in today's environment, today's students are far more advanced than what we used to do. If you look at what is happening in academia, they are all about what they call PBL, project-based learning.
Uh-huh.
And all of it has to do with hardware. They're using hardware in the control class. They're using hardware, of course, in the electrical engineering and computer science, as you can imagine.
Sure.
But there's the whole new area of robotics and mechatronics and biology, where they're actually using Arduino to test all kinds of signals.
Mm-hmm.
So the world that we grew up in, where hardware was rarely used, in today's academia, everybody's using it in many different disciplines. And it's true that probably a student could get access to MATLAB and Simulink on campus for free, because we do work with most of the universities around the world.
Uh-huh.
But we also realized that students today really want to get access at home and on their laptop.
Sure.
And this is why we are providing the student version that gives you MATLAB and Simulink and 10 of the most commonly used products for $99.
Cheap. All right.
That's pretty cool.
Mm-hmm. All right. So tell me, what kind of projects do you see students doing?
Well, we see students develop autonomous roboboats.
Cool. Okay.
Actually, the picture on the bottom left that you see was taken from the International Student Robobot Competition that was held in Virginia in July. And the student teams were supposed to develop an autonomous boat that has to navigate through a channel and through the way identify and avoid obstacles.
Cool.
And they did it either by visual terms, thermal terms, and acoustically.
Okay.
So it's a very complex system.
Yeah.
The picture on the bottom right is actually taken from a student competition in Germany, where the competing teams had to spend about a year to design, build, and test their cars. And then they got together to show off their work in front of the judges.
Super cool.
I believe we have a video that talks about this competition and how those students were using MATLAB and Simulink.
Yes, let's see it.
Awesome.
Formula Student Germany is a design competition for students. They build a race car and then they have to compete in different disciplines, and who gets the most points wins in the end. One of the biggest challenges is to get everything ready for that 1 week of competition.
What you see in class, usually you don't apply at school. Now you have a very good chance to get your hands dirty. It's very important all the key members learn MATLAB because that's what we use a lot.
We have static events and dynamic events. Static events are cost, design, and business. We have a skid pad, which is basically a figure 8, acceleration from 0 to 75 meters, an autocross, and an endurance event, which is 22 kilometers long.
We use MATLAB and Simulink to simulate the behavior of our tires, how they react on the racetrack.
I use Simulink for design of the disc brakes and choosing which disc brakes and pads I use for one competition.
I use MATLAB and Simulink primarily focused on the suspension design and vehicle dynamics. The design of the wings was based upon a DOE, a design of experiments, and then another optimization study using MATLAB and Simulink to apply external loads to our vehicle in another simulation environment. And when the drivers went out, the car handled flawlessly and we made basically no changes.
We always have the problem that we have to calculate the power we can give to the motors. To do this, we process the data we have with MATLAB Simulink and we simulate the system and find the energy we can give to actually finish endurance.
One of the most difficult events is the wet skid pad because we have to set up the car for wet conditions. When we go testing outside, we gather a lot of data and we use MATLAB to sort data very quickly, very efficiently. And we're able to give hints to the driver and also give hints to on the setup of the car way more faster.
MATLAB and Simulink, we were able to start off with looking at the simplified vehicle model. So something you're just writing in a simple, one-page Simulink block. And then from there, we can tie it into other commercial softwares that are representing our full vehicle. And we can set up DOEs, optimizations, and basically run through our entire vehicle virtually before it even exists in CAD.
MATLAB Simulink was for us very important because the simulation abilities of the software is incredible.
We can do complex simulation or just on the corner simulation for some idea we have. It's really fast, it's really efficient, and it's really easy to use.
MATLAB and Simulink comes first in our design process.
Just great experience to build your own race car and have it and be able to drive it. In the end, it is about the fun in doing it.
That was super cool. Way cooler than anything I ever did in high school, that's for sure. So tell me a bit more about how you're seeing the MathWorks in the industry.
So what we see in the industry is that, of course, many of our customers who develop their MATLAB and Simulink algorithms are trying eventually to get into a hardware platforms. Mm-hmm. They're trying to implement their video algorithm or audio algorithm or whatever it is on an embedded platform that ends up in our cars, in our cell phones, in our overhead projectors, in pretty much everything we touch in these days.
Sure.
And for that, they're using what we call a model-based design methodology.
Ah, I've heard of that before.
Yeah, a model-based design methodology is a methodology that allows you to first spend a lot of time in simulation to make sure that you're designing what exactly you should be designing.
Right.
But then, of course, we know that when you go to the hardware, things are starting to get a little bit messy.
Yeah.
And they do change. And for that, MathWorks has developed code generation engines that allows you to take the simulation and generate C code that can go into a microprocessor or a DSP. We also generate HDL that can go into an FPGA or an ASIC.
Okay.
And we also do PLCs. And the notion about model-based design is that you continuously verify your system until the hardware implementation matches the software simulation.
Right.
And this is how we connect to hardware.
Okay, so how optimized is the code?
That's an excellent question. And I think we realize that our code cannot be optimized to all the software platforms that are out there.
Right.
And this is why we are working with the semiconductor OEMs. So you can see that Freescale is taking our code and developing their own motor control development toolbox.
Cool, okay.
Based on our code generation. Texas Instruments has been doing the same for their Hercules device, which is a critical safety application. We also has a MathWorks workflow that targets the TI-C2000 family.
Okay.
And we do work with analog devices, with ST Micro, Microchip, and so on and so forth, to make sure that the code we generate is optimized to the devices that our customers are targeting.
All right, all of these are C-based vendors, but what about the hardware guys?
Oh, the hardware guys are extremely important to us. And we have a tool, we call it HDL Coder, that generate RTL, VHDL or Verilog out of your Simulink blocks.
Okay.
We also partner with the big FPGA vendors, with Xilinx and Altera, where they develop their own tools based on Simulink. Xilinx called it Xilinx System Generator,
okay,
and Altera called it Altera DSP Builder. And as you can see, real customers who are using this model-based design methodology for hardware are achieving tremendous results. BAE was able to reduce development time in 80%.
Wow.
That's huge.
Yeah, that is huge. Okay, so it seems like you guys support quite a few hardware platforms.
Yes, we do. And in fact, Amelia, we support more than 150 hardware platforms.
Wow.
And you can find the list of those platforms where we have optimized code for on our website at mathworks.com/hardware. And not surprisingly, I think you can see ARM at the very top. Everybody is using an ARM core today.
Yeah.
The hardware guys and the software guys. And we have those optimization tools for the Cortex-A, Cortex-R, and Cortex-M.
Okay, so we've talked about the makers and academia, but you guys also have a huge presence in the industrial world. Is that right?
That is very correct. And in fact, MathWorks serves all the different type of industries because what our customers are doing with our tools is math-based.
Right.
So it's not only for aerospace and defense, and it's not only for automotive, or it's not only for communication. The portfolio of the things that our customers are doing with our tools goes into medical, goes into biotechnology, and all kind of sorts of applications where you have a math-based application.
Sure.
And the code generation and the model-based design methodology is really prominent in those markets because it helps our customers get their products to market faster. And I bet you that all of us, or most of us, probably have been driving a car recently that uses MathWorks code generation tools on an embedded platform in their cars.
Cool.
When you guys came over here, you probably flew an airplane.
Yes, we did.
I bet you that the airplane has been using, or in this airplane has been using MathWorks code generation technology.
Cool.
So these are just a few of the industrial applications we are involved in.
Okay, so we've talked about several different groups of people. So if I'm ready to get started and I'm a maker, for instance, which I am, what would I do first?
If you are a maker, I would suggest you go to the Maker Zone.
Okay.
And see how you want to get started. And I don't know if you have an Arduino or Raspberry Pi or a Lego in mind, but based on the platform that you have, you can go into the website and see dozens of examples of how to get started. And you can also ask questions and get answers right away.
Nice. All right, so what about for the students?
The student is really where MathWorks has been very strong for so many years. And we have been developing curriculum with professors, which are available on our site. We have what I mentioned before, the PBLs, the project-based learning. And even those materials were developed either by students or for students. That doesn't mean that anybody else can use them.
Right.
So I would go to mathworks.com/academia.
All right. Now for my professional engineering audience, where do they go for more information?
The professional audience would go to MATLAB Central, which is the community for the users of MATLAB and Simulink. And this community has been very vibrant for more than 10 years now. And it has 70,000 daily visits. And that means that there's a lot of useful information. And it's not only information that MathWorks has been contributing to. It is mainly information and data and examples that our customers have been contributing to.
Very cool.
And if you're going to pose a question on MATLAB Central, it is likely that one of your peers in the market will get back to you before a MathWorks employee will get back to you.
Nice. All right, I think I'm ready for a recap, but let's go.
Okay, so in summary, what was important to communicate today is that MathWorks connects to hardware.
Yes.
And we have been doing it for 20 years now, so it's not new to us. And the reason why we connect to hardware is because we make programming hardware much easier. It's also important to us to let people know that we have licenses for students and for the maker community. And no matter where level you are at, they're going to be getting started resources that can help you get started on your project.
Excellent.
But you need to remember, you need to be patient because hardware is still hard.
Yes.
Or as we say, hardware is hard, but with MATLAB and Simulink, it's easyware.
I love it. Well, it was a pleasure learning about all of this. Thank you so much for joining me today.
The pleasure was mine.
Before we go, don't forget to click that link. There you can download a free tech packet with all sorts of information about how the MathWorks connects to hardware. For Chalk Talks, I'm Amelia Dalton. For more Chalk Talks, check out the EE Journal YouTube channel or the on-demand section of eejournal.com.